All right, this is section 9.6. For the people who are gone, this is a recording. I am teaching this lesson at the same time, so bear with us. If you need to skip through some parts, if I'm taking too long, whatever, that's fine, I don't care. So, secant, tangents, and angle measures. Basically, you've got a lot of lines running through a circle, and you're trying to figure out some angles associated with them. There are patterns to these according to how the lines are intersecting with one another, okay? So, yesterday we dealt with tangent lines. What does a tangent line do to a circle? What's a tangent line look like? A line? How so? What's a tangent line look like? Oh, I'm so delayed. What's a tangent line look like? It touches at one point. So if I pick a point right here, it's going to like graze that point. That's what a tangent line looks like. Tangent. Okay? Now, these are called secant lines. Secant lines are like chords that are extended. That's basically what they are. Okay? They go through and they touch at 2 points. This is called a secant line. They're basically like chords that are extended. Okay? Pretty easy concept. Okay? Now, you're going to have a couple secant lines that are interacting with each other. Okay? So, and they're trying to find the measure of like these angles associated inside of here where they cross, okay? So, referring to just angle 2 here, okay? Let's say AD, this little arc, they tell us is, I don't know, 40 degrees. Let's say that that's 40 degrees. And let's say that this one right here is 60 degrees, this arc right here, okay? What you do to find the measure of angle 2 is you add them together and you divide by 2. So I would take angle 2 is equal to 40 plus 60, and I divide by 2. What does that make? 40 plus 60 divided by 2. 50. This angle 2 would be 50 degrees. Okay? Now, how can you find angle 1 from there then? How do you find angle 1 if I know that that's 50? Yeah, subtract from 180. 1 and 2 live on a straight line, right? So 180 minus 50 is 130, and that's what angle 1 is, right? Easy peasy, okay? You add them together, you divide by 2. It's like taking the average. When those secant lines cross on the inside of that circle, it's like taking the average, okay? Go down here to these questions. So this is exactly like what I was illustrating angle X right here. We're going to add 84, and we're going to add 130 together, okay? That is 214. Check me. 84 plus 130. Yes? Divide by 2. And that is 107. 107 degrees is what angle X is. Okay? You add them together, divide by 2. It's like taking the average. Okay? Now the second one. That one is a little bit tricky because angle X is not the angle that we're talking about. Right? If we add 143 and 75 together and divide by 2, it will give me this one or this one, right? It will give me the left and right one, but I want the X, right? So we're going to go ahead and find these ones that I marked in blue, but then we're going to subtract to find that X. Does that make sense? Okay? So we're still going to do the average. We're going to do 143 plus 75 divided by 2. What does that make? 109, okay? So that means this guy's 109 and this guy's 109. Ran out of room in there. 109. How do I know that those two are the same, by the way? How do I know that they're like both the same measure? You know what those two types of angles are called? And they're across each other like that? Vertical angles. Vertical angles, okay? So that's 109. We need to figure out what X is. So we subtract from 180 because they live on this straight line here, right? So 180 minus 109 is 71, maybe. Yeah? 71? Perfect. Okay? All right, now, this one's even harder than that because they're going back the other direction, okay? 110 is the angle that we're usually trying to find, right? 110 is what it would give me if I take this arc and add them together and divide by 2, right? This arc is 97 plus X, and I would divide by 2 to get 110, right? So we're just going to set it up to look like that, right? 110 is the answer now, and we're setting it up, and now we have to work backwards, right? So how do I work backwards and solve for that X then? Multiply the 2 over, yep. Times 2 times 2, 110 times 2. 220 equals 97 plus x. And then, last thing, subtract 97. Minus 97. Okay, so x is, I can't do that math. 123, thank you. 123 degrees is what this side is. 123 degrees. Okay. Now, notice that these lines are not intersecting at the center of the circle, right? Okay. If they were intersecting at the center of the circle, this would just be 123 degrees, or it would be just 110 degrees. Right? If that was a central angle and it was 110, then that would just be 110. Right? But it's not because they're not intersecting at the center of the circle. It's not a central angle. Right? Okay? All right, so moving on down. Now we have talking about these angles here. Right? Those two angles. And this is a tangent line and a secant line. So we've got, instead of 2 secants, we've got 1 tangent and 1 secant line intersecting with one another. Okay? So they're intersecting at the point of tangent. See, basically I have like 2 sections. It's like slicing my circle in half. Well, not in half, but if we slice the circle in half, I want this side. If we're talking about like a pie or a cake or something, I want that side, right? Okay, so here's how this works. Let's say that this is 160 degrees over here and this is 200 degrees over here. Okay, these arcs, 160 here and 200 degrees there. You see that? Okay, now they all have to add it to 360 because that's what a full circle is. But this arc right here is 200 degrees and this is 160 degrees. Let's pretend that. Okay. Now, angle 1 and angle 2. How can you find those? It tells you it's just half. So angle 2 is half of 200. So this guy would just be 100, and this guy would be 80. It's just half of where that arc is. When a tangent line and a secant line come together, you don't really have to like add together and divide by 2, or subtract and divide by 2, or whatever. You have just taking it in half. Yeah? Good? Okay, so questions down here. This arc right here is 148. Okay, that's what's labeled. They want to know the measure of QPR. QPR is this angle here. Okay, so how do you find that angle of that guy rather than the arc? I want to know that angle that's made by those 2 lines. How do we do that? Divide by 2. 148 divided by 2. 74 degrees. So this angle that's made by those 2 lines is 74 degrees. Yeah? Okay, now, they kind of do some different things to you. They say this angle right here is 64. Do you see how that's kind of touching that angle? Okay? They want to know what DEF is. They want to know this way around the circle. Okay? So we've got to kind of do a couple steps before we do this, right? If this is 64, I'm going to find this blue arc first. Okay, what's that blue arc going to be? 128, you double it now. 128 degrees. Now how can I find this other half of it, or that other part of it? Subtract from 360. 360 minus 128 is something. I don't know. 232. Yeah? Okay. Perfect. There you go. So sometimes you might have to do something and solve for something that you don't need, but you need it to solve the other thing that you actually do need. That was a lot. Okay. Backside. All right. Last concept. So we just did 2 secant lines intersecting inside of a circle. Then we had a secant and a tangent, like this. Okay? And this one you add and then divide by 2. This one you just divide by 2. And then we're going to have something else going on where we have 2 secant lines that are intersecting outside of a circle. Okay? In this one, you're going to subtract and then divide by 2. Okay? So there's kind of a common theme. If they're intersecting inside of the circle, you add these 2 arcs together and divide by 2. These are the 2 things you're adding. This guy and this guy, you're adding those together and you're dividing by 2 to get this angle. Okay? when you have a tangent line and a secant line, let's say you're trying to find this angle, you just divide that guy by 2, okay? And if you're trying to find this angle inside of here, you subtract those 2 arcs from each other and divide by 2, okay? So it depends on where they're intersecting. Inside the circle, outside the circle, like on the circle basically, okay? So this backside, we're going to be subtracting the 2 arcs and dividing by 2. Okay, so we have this question going on here. Actually, let's go back up here. I'll give you some examples. Let's say I'm trying to find this little angle right here. Okay, and this guy is 100, and this guy is 40. Okay, I'm talking about the 2 arcs, 100, 40. Okay, and I want to know what that little angle is. Okay, I'm tempted to say that that little angle is 40 also, but it's not. Okay, I subtract the 2. So I do 100 minus 40, and I divide that by 2. 100 minus 40 is 60 divided by 2. This angle right here is 30. Okay, you get the idea? Okay, you take the bigger one minus the smaller one, and then you divide that by 2 to get what the little tiny angle is. Okay, all right, so let's go down here. They want us to find this little angle L, which I'm tempted to say is 102, but I know that's not right. Because angle L, well, it's kind of an obtuse angle. Maybe it's right. 102 is the only thing that we have up there for angles. And it tells me that the measure of the arc here is 102. Yeah, 102. This little arcy thing right here. I don't even have what the other one is, right? Don't I have to know what this side is in order to be able to subtract? But I don't have it. Yes, I can figure that out because these 2 have to add up to be 360. So 360 minus 102 is 258. Did I do that right? So now I have both of them. 258 and 102, I can figure out what this little angle is by 258 minus 102 divided by 2, whatever that is, something, something. What? 78 degrees. 78, are you sure? Yeah, you're probably right. 78 degrees. Okay. Okay. Yeah, it is like it is at a cute angle. I don't know. I don't know. That's very close to a right angle to me. I don't know. Anyway, subtract, divide by 2. Okay, over here. Now this is backwards. Okay, normally we're solving for this guy. Or no, normally we're solving for the 56. And we have this guy and we have that guy. And we're trying to find this arc, DC. So let's call it X. Okay, we're going to label him as X. So how am I going to set up this equation so that I can solve? Normally we're solving for the thing that's labeled 56. So we have the answer basically. We're going to have to work this backwards. So normally now I have the answer. The answer is 56. Where does all the other junk go? It's kind of like the one that we, from the front side, that we unwound. Yep, X minus 95. We're still taking this guy and subtracting this one, and then dividing that by 2. Okay, now we unwind it just like we did before. Multiply by 2. Okay, 56 times 2 is 112. Is that right? Okay, so 112, X minus 95. Add 95. So that big arc is, I don't know. What? 207. Okay, now we can check our answer to make sure we're right. No, we can't. No, we can't. I was going to say we can add those 2 together and make sure that they're 360, but why will that not work? These 2 don't add up to be 360. Why not? Right, part of it, that BD on the top, that part is not in the circle, so we can't just check it. I was going to check our answer, but we can't do that. Okay, so 207 is the answer. We have to work those backwards. So just set up the formula just like you would do before. Okay? All right, now this is a planet problem. The diagram shows the path of light ray as it hits, no, it's a drop of water, not a planet, but same difference, right? Light ray, as it hits a drop of water, the rays are bent or refracted. Did you guys know that? You should know that. That's like a 7th grade, maybe even a 6th grade thing. Like if you stick a ruler in water, you know how it's like, it curves. Okay. At points A, B, and C, if the measure of arc AC, let's label that. Arc AC right here is 128. Okay? And XBY, this arc right here is 84. Now those should not add up to be 100 or 360 either, because you see this little bottom part right here that's not accounted for, and this top part that's not accounted for, right? So those should not add up to 360, and that's okay. They want to know what angle D is. Okay, so this is the angle of refraction. Okay, so is that one where we have to add them, just divide by 2, or subtract them and then divide by 2? And you have your little key code up here. If they're intersecting inside the circle, you add them and divide by 2. If they're outside the circle, you subtract them and divide by 2. If it's just on the circle, you just divide by 2. Which one are we doing here? We're subtracting. They're outside the circle. So what am I going to subtract? What do you subtract? 128 minus 84, which is 44 divided by 2. Did I do that right? 22 degrees is angle D. Okay, good? Yes? Okay, so these are ways that lines are intersecting inside circles. 3 concepts. If they are on the circle like this, where you have one tangent line and one secant line, okay, you are just dividing by 2. Just divide by 2. If they are intersecting inside the circle, inside, I'm underlining that, then you are adding and divide by 2. You add these 2 arcs together and divide that by 2. And if they are intersecting outside the circle, kind of making like a little coney thing, outside the circle, you subtract the 2 arcs. Subtract and divide by 2. Okay? So, pretty easy concepts. You just have to figure out which one you're doing. Okay? So decide that first when you're doing your problem. Some of them you're going to have to work backwards, because you're solving for one of the arcs and not the angles. Yeah? Good? Okay, that's all.